Imagine trying to spot a firefly flying in front of a stadium spotlight from 1,000 miles away. That's essentially what astronomers are doing when they hunt for planets orbiting distant stars. Welcome to one of the most mind-blowing detective stories in modern science. We're talking about finding planets that are literally invisible to our most powerful telescopes, worlds orbiting stars so far away that their light takes years, decades, even centuries to reach us. The challenge is astronomical in every sense of the word. You see, planets don't produce their own light like stars do. They're essentially dark objects reflecting tiny amounts of starlight, making them incredibly difficult to spot directly against the overwhelming glare of their parent stars. It would be like trying to see a speck of dust floating near a searchlight from miles away. So how do we do it? Through brilliant indirect methods that reveal planets by their effects rather than by seeing them directly. The most successful technique is called the transit method. Picture this. When a planet passes directly between us and its star, it blocks a tiny fraction of the star's light. We're talking about drops in brightness of just 0.01% or less for an Earth-sized planet orbiting a Sun-like star. But our instruments are so sensitive they can detect these minuscule changes. It's like noticing when a mosquito flies in front of a car's headlight from a mile away. The Kepler Space Telescope revolutionized this method, staring at one patch of sky for years and monitoring the brightness of over 150,000 stars simultaneously. This relentless monitoring allowed it to catch these brief planetary transits, some lasting just a few hours. Through this method alone, Kepler discovered over 2,600 confirmed exoplanets and thousands more candidates. Then there's the radial velocity method, which detects planets by the gravitational wobble they cause in their host stars. As a planet orbits, its gravity pulls the star back and forth, causing tiny shifts in the star's light spectrum. These shifts are so small they're equivalent to measuring the speed change of someone walking at normal pace by just a few centimeters per second. But again, our instruments are precise enough to detect these subtle movements. This method was actually how the first exoplanet around a Sun-like star was discovered back in 1995. The planet 51 Pegasi b shocked astronomers because it was a hot Jupiter, a gas giant orbiting incredibly close to its star, completing an orbit in just 4 days. This discovery overturned our previous theories about planetary formation. More recently, we've developed direct imaging techniques that can actually block out the star's light to reveal planets directly. This is incredibly challenging and has only worked for a handful of planets, mostly young, hot gas giants far from their stars. But the technology is improving rapidly. What's truly staggering is the sheer number of planets we've found. As of now, we've confirmed over 5,000 exoplanets, and statistical analysis suggests there are likely billions of planets in our galaxy alone. Many of these are in what we call the habitable zone, the distance from a star where temperatures could allow liquid water to exist. The search for Earth-like planets in habitable zones is one of the most exciting frontiers. Planets like Kepler 452b, dubbed Earth's cousin, orbit in similar conditions to our own planet. While we haven't found definitive signs of life yet, the discovery of so many potentially habitable worlds suggests the ingredients for life might be common throughout the universe. Future missions like the James Webb Space Telescope and the upcoming Roman Space Telescope will take this search to the next level, analyzing the atmospheres of these distant worlds for biosignatures, chemical signs that could indicate biological activity. The implications are profound. Every new exoplanet discovery brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? The methods we've developed to find these distant worlds represent some of the most ingenious scientific detective work ever conceived, turning what seemed impossible just decades ago into routine astronomical discovery. Which exoplanet discovery has amazed you the most? Share your thoughts in the comments below.